Alright, let's go ahead and look at post-exploitation using a rootkit. Now, what I'm doing is I'm going to just show you a couple things here. First, let's get rid of netcat because we're going to need to do a proof of concept by bringing our own over. But what I want to show you here is in inetpub on this IIS web server here, we can see that this is the default home page. It just says it's protected from hackers, blah, blah, blah. Just a regular page, nothing fancy on it. And if we go here and look at the settings in the IIS administrator documents, we can see that my page.html is a page that it's serving up when someone visits this website. Alright, so what we're going to do is we're going to go ahead and exploit this thing, and we're going to do a couple things to it. But first, I just want to do a quick nmap scan, just to simulate some recon. I mean, we've got other videos and articles about recon, but I'm just going to do an nmap-a against this guy and let you see what ports are open, what services are running, and make sure I got the right IP. It is 132. Alright, so back to our Linux here. So we're going to scan port 80 on that machine, and I just did -a to do some of the advanced things like host discovery and web discovery. So we can see here that it came back and told us that it's running IIS 6. Okay, so there are a few assumptions we can make here. Number one is, we know that the default directory that IIS stores stuff in, or your home page is stored in, is inetpub root. So we can make that assumption. Now there's other discovery things we could do if we needed to validate that, but we're just going to do is I'm simply going to browse to that page or browse to that web server's IP, and we'll see what page it actually serves up, which is this page we're looking at here. Page is safe, hacker free, tested and verified, woohoo. Alright. So essentially, I've already started Metasploit up here, and I'm going to use this classic exploit. Again, this is not really per se an exploit focused video. This is more post-exploitation. We've made other videos, other articles on how to exploit and how to get on the box. So this is to show you some interesting things you can do once you're actually on there, as far as post-exploitation, maintaining access and things of that nature. Alright, so we're just setting our variables here, and again, if you want to see like what these settings mean and how to set up Metasploit and all of that good stuff, we've got several videos. Andrew Whitaker just posted a really good one, with client-side stuff on Adobe Reader. I've got a DLL hijacking one that was put up recently, so you can go there and see some of this. Now, it tells us here we got a shell. Alright, so we're going to just utilize a shell. So we've got a shell. Again, since we exploit RPC, we are running a system, so we can do whatever we want here because that service runs a system. Now, in this inetpub root, we can see that there's a mypage.html here. Okay, so that is the page that we're going to need to get over. So I'm just going to TFTP a copy of it over to this Linux box, which is 112. Alright, so it's there. Alright, and then I'm just going to do another test here just to make sure we got the right one, because remember, we don't have physical access to this box. So I'm just going to have Firefox open that copy that we just pulled over to my TFTP server here on my Linux, and we can see, okay, that's the same page, so it's probably that page. Alright, so what we're going to do is we're going to first basically make this thing into a browse by web page. In other words, we're going to do a client-side exploit to where anybody that browses this page gets exploited if they're using Internet Explorer. So what you see here is just a basic iframe. There's nothing fancy about it. For these purposes, I'm pointing it to the IP address of my Linux because I'm going to have a client-side exploit running there. I gave it a height. Actually, let's make it a height. Let's go ahead and save it first. All right, so this is the actual iframe. Okay, I'm just going to copy that text from that frame into this web page that I copied over from the victim web server. Okay, so that iframe is saying, make a call to that IP, and you'll see why that's relevant later. Let me get that back out of my, get it back into my cache here. All right, paste. Okay, there we go. So this frame could be any size you want, but we want it to kind of be invisible. We could use invisible tags and things like that. But for now, I'm just going to go ahead and make it a height of 100 and a height of 0 and a width of 100. So therefore, it's invisible. Let's just do 100 and 100 for now, because I want you to see that frame. Just in case you don't know what an iframe is, let's just go ahead and take a look at it, and we'll see it show up in the page. All right, so see this little guy here. This is the actual piece of HTML we just put in. That's the iframe. It's essentially one way to think of it as a web page inside a web page. So we made a call to another resource inside this page. Now the significance of this is if you look at log files, you're not going to see a redirect or refer page because this is all coming from within this iframe. So as you can see, I did make the height 0 because we want it to be invisible, relatively speaking. Now, we should see a line here, and this is because we're using Firefox. Now, this exploit, I'm primarily using it against Internet Explorer, which we won't see that line in IE, and we can make it go away with in Firefox as well. Okay, so we got that page configured like we want. So now what we need to do is replace the real home page with our version of it. So first I'm going to rename the victim's home page to mypage.htm, which now is going to allow me to TFTP my version of it over. All right, so we got my version there, and that's the page that's going to be served now when somebody visits this site. Again, we can prove this by visiting it. Let's just go back to that IP. So that's the page we got. Now we want to make sure the one on the real web server matches that. All right, so there we go. Refresh this. So we can see that, our iframe is there. All right, so we're halfway there. We've replaced their page with our iframed version of their page. Simple as that. Now we'll get into some of the more advanced part, which is really the post-exploitation stuff. We're going to basically use a known rootkit to hide the web page from the victim and essentially hide it from Windows as well. And then we're going to show you some other things we can do with it as well. All right, so we got our successful transfer. The page is loaded. We can see that everything looks good there. So if we go back and play the victim, actually we don't need to do that. Let's just go ahead and get out of our exploit here. All right, so what I'm going to do is actually load the client-side exploit. And, even though this is not for exploitation, maybe you can pick up some things here as well. So I'm just going to search for that chunk size exploit that exploits Internet Explorer primarily. It does work against older versions of Firefox as well. So I'm searching for that, the any load image chunk size exploit. And you can see Metasploits comes back and shows us two of those. One is the email, which allows you to email the same HTML page to a victim. But we're using the browser one because we want people that browse this web page to actually get exploited by this. So we need to set a couple things. Lhost, which is going to be my IP, of course. We need to set server port, which is 80 because we want this thing to act as a web server. And then the URI path, we're just going to make that root, and we'll set an L port to 7744. And this L port is arbitrary. Right. Let's see, L port. All right, yeah, we need to set a payload. So we're going to use generic shell. Again, there's other videos. TCP. Oh, it took 2 G's there. Generic shell. Reverse TCP. There's other videos where we get into interpreter and some other more exciting payloads, but the payload's not really what we're illustrating here. So we'll just use the basic shell one. And then we're just going to simply fire off the exploit here. And what that's going to do is it's going to make this Apache server launch and listen on port 80. And anybody that visits it is going to get served this page exploit that is carefully crafted to exploit how Windows handles, or how Internet Explorer handles cursors and animations. Now what happens is when somebody visits it, and we'll make the victim visit the page himself, so we'll just go localhost. Alright, what you see is, you can see in the bottom here, you can see we went to localhost. You can see the page looks exactly the same, but what we got on this side is we actually got a shell, and that's because we just exploited Internet Explorer on that particular machine. Now, if someone else were to visit his website, not him, but anybody running this version of Internet Explorer, they get exploited too. So what we're going to see here is we get a shell based on that fact. Alright, so we can see that we're on there. We IP config, that is the victim, so we know we got the right guy. Alright, so we can see that the exploit works, the iframe works, we replace the page. Now we not only get that guy, but we get people that visit this particular website as well. Okay, but now we need to get into how we're going to utilize this rootkit. Okay, so I'm going to show you a couple of things, but first we'll go ahead and reload that first exploit that we used, the RPC one. That payload's great. And then we'll still need to set an L host and an R host. Get back to that. Alright. So there we go. L host is going to be the same. Our host is going to be that same victim, 132, because we want to get back in there. And now we're going to do some post-exploitation stuff with this hxdef rootkit. Now keep in mind, guys, this is a public video, so no, I'm not going to demonstrate to the world how to use a unknown or a unsignaturized rootkit to do some of these things. We do exercise some level of responsibility here on what we put out publicly, but this is just to give you an idea of what could happen. Because if you don't have to be creative at all to find rootkits that don't have a signature. All right, so basically we're back in. We exploited again. Now, in this temp directory on my Linux box, this is basically my TFTP store. There's a file in there that I'm going to get ready to show you here. It's called hxdef 100.ini, and this is the ini file for the hxdef or Hacker Defender rootkit. Okay, so we can see that by default what it's doing is it's hiding anything that begins with the characters hxdef. And we've also got calc in there. This is from another demonstration. So replace that with netcat because we want to hide netcat. Alright. So we hid netcat from processes and table. But we also want to hide that actual web page that we put over there that replaced the original one. Remember, we got the iframe in there. So we're going to hide that web page from Windows as a whole. Okay. So what should happen is Windows shouldn't be able to see it. Now down here we can see that basically rcommand.exe can see all this stuff. Everything else is hidden from except for rcommand. What I'm doing is putting in w3wp.exe, which is the IIS service that actually serves the web page. So what I'm saying is hide it from everybody except for rcommand and w3wp.exe. So the process in IIS that needs to serve the page will be able to see the page, because if it can't see it, it can't serve it. But nothing else on this Windows machine should be able to see the page. Now we could put those tags there if we wanted. We don't need to actually put those there. Now a couple other things it does. It's going to start netcat to listen on port 100 so that we get a shell. So I want to hide port 100, and this is what I'm doing under hidden ports here. Input and output, because if you don't hide them both, it'll still be some visibility. Now we don't need to hide UDP unless we're going to do some UDP types of communications with netcat. But we'll just do it for uniformity. All right, so this is all of our settings. Now I'm going to save that. Okay, so now my next step is I need to get that file as well as the .exe file that runs on this INI over to this victim that we've compromised. So I'm going to put that file over, the INI file. Actually, I'll get netcat first because we need that on the C drive. All right, so we can see that it's there, because remember the rootkit's going to try to launch it. If it's not where you say in the INI, then it's going to fail launching it. So we put it where the rootkit has, and we could have changed the location as well. But now we need to get the INI file itself over, and we need to get the executable that runs off that INI, which is .exe, and then I'll go ahead and get the INI that we just edited over as well. All right, and then I'm simply going to launch the rootkit, and then we'll test to see if it hid any of these things from us. All right, so a task list gives us a quick view of what's running. Notice it's just normal Windows Server stuff. All right. So let's get out of this session. And now let's go and see what the victim is actually able to see. Now we can telnet to port 100. Remember, because we told netcat to listen on 100. And when we telnet, we do get a shell on the victim machine. So netcat's listening, that's great. So we know the kit was able to successfully launch netcat. But the challenge here is, what's the victim going to see as a result of this? Now, we know that page, we hid it, or at least we think we did, but did we hide it in a fashion that the page doesn't actually load like it's supposed to? Let's try that and see if when we go to localhost, we still get exploited. Let's go back here for a second first. And we'll get our client-side exploit running again, so there's something that's actually listening when that HTTP call comes in. And past it, there we go. And we'll just go ahead and set these other options manually here. I tend to get them faster typing them than doing the up arrow to go back to the history. Plus, it's good practice. You never forget the commands. But the problem with it is just like you saw, typos galore. All right, there we go. All right, so we need to set our L host again. That's going to be our own IP here. And then we'll set the SRV port, which again is 80. Now, something's going to happen here, and I want you to see this, because if you have never seen this message, this error before, that should pop up here. There we go. Notice it says the supplied resource is already added. Now, I've seen people try to demonstrate this, and they get this, and then they'll do rexploit like so to reload it, and it still get the same error. It's because that port, that resource and that port's still in use. Now, all we have to do, actually, I didn't mean to get out. I was going to show you how to stop it from the MSF prompt, but also getting out of Metasploit and getting back in stops it as well. So while we're waiting for that, let's go ahead and check a couple things out here. So if we go to inetpub www.root on the victim, notice that mypage.html is missing. You see mypage.htm, that's the one we renamed, but the actual page that's being, or that should be being served up is missing. All right. So that means it's not there. Well, what happens? So the challenge here is it still going to serve out the exploited page, or the page with the iframe in it, when we actually try to browse to this web server? Because we can see that it's hidden from Windows. We didn't see mypage.html. We see it's hidden from Windows, but is it hidden so well that the web server won't be able to launch it? Now notice netstat shows us there's nothing listening on port 100. Nothing at all in this list. Okay? But if that's true, and I'll scroll down and let you see the whole thing. If that's true, then how is it that we're able to go back? Let's get a shell here. How are we able to telnet to port 100 if there's nothing listening on port 100? So this is the first piece of it. You've got a backdoor that's really hard to detect from any traditional examinations that you do on the victim side. I mean, we run netstat, we run task manager, we run TCP view and process explorer and some other things, and we don't see anything listening on port 100. And I'm just reloading my client-side exploit here so that we can test to see that the page is actually being served properly, that we went through all that work to put over there. It actually has the exploit in it. And I'm just setting the same variables we set earlier. We need an L port. Alright, so notice when I say exploit, we don't get that error message this time because we killed a previous listener. Now, let's test it to make sure that it's still serving the right page when we go to localhost. Okay, we can see at the bottom here, and I left this in here for this, just for this illustration. We can see that the iframe is still loading the exploit, and we can see on the Linux side we're able to still get a session on that victim machine. So that mypage.html that's obviously hidden from Windows is being served because we told it to hide it from everything in Windows except for the W3WP service. Okay, so we can see that we do have a shell on that machine, even though that page that's hosting that client-side exploit, or that iframe that points to the client-side exploit, is actually not visible on the victim. And that's kind of what we were after there. All right, now if we go look in inetpub www.root, we can see indeed that mypage.html is not there. So then the question becomes, okay, how is the page being served out if Windows can't see it? And the answer to that is we didn't hide it completely. We just hid it from everything in Windows except for that particular service, the W3WP service that's running and serving the pages. So if we go to directory here, we can see my page, but we can't see mypage.html. It's totally gone. But yet somehow it's still being served. Now, that's essentially it, and that's how it works. Now, that's the exploit. Again, just for the sake of reviewing, what we did is we exploited the web server. We replaced their page with our version of the page that had a hidden iframe in it. the iframe points to a client-side exploit running actually on top of our uh, Linux server under Apache. So we've got Apache serving out a page that exploits a vulnerability in IIS. So that we saw that all works. But then the post-exploitation part that we did was once we got that there and we got that loaded, was we used the Hacker Defender rootkit to actually hide the web page from Windows. And not only that, we had it to launch netcat to listen on port 100, and we hid netcat and we hid the listening port of 100. Now, again, traditional forensics is going to not get you far there, especially if this is a web server that you can't easily take down. Primarily what I'm talking about is live forensics. Traditional live forensics will get you nowhere when someone's gotten this deep post-exploitation wise on the system. Now, in the very next video that I'm going to put up right behind this one, I'm going to take this same infected machine and we're going to look at it forensically from a newer way, just a different way of looking at forensics. Because as you can see here, you can't see everything just by looking at the hard drive. And again, if this is a server that can't be down immediately, well, you don't have the option of yanking the hard drive out. So we're going to approach it from a live forensics perspective and look at it from the outside in versus trying to go to the victim and see what we can see from the victim, because you have to make the assumption that if someone's truly on that web server or truly on your web server, then anything that you would normally do to detect what's going on from the victim is probably going to be relatively useless. So we're going to take a look at it just using some basic tools, look at it from the outside, and then be able to actually see something's not quite right on that server. So I hope you enjoyed this, and go ahead and jump right over and look at the next one, which is where we're going to forensically take a look at this.